Hi, in today's video, I'm going to talk about how to create a confidence interval when you have a set of sample data. Sometimes we want to perform inference about a population's parameter, and we can do this by using sample data when we have certain conditions that are met. In the following example, we are asked to determine whether the expectation of good weather leads to more generous behavior. The question says, psychologists studied the size of the tip in a restaurant when a message indicating that the next day's weather would be good was written on the bill. Here are tips from 20 patrons measured in percent of the total bill. In this question, we are not given that we know anything about the population of tips. We don't know whether it was normally distributed or not. And so in order to determine whether we can perform normal calculations, we typically have three different conditions, or three different ways that we check whether we can perform normal calculations. The first is if we know that the population that we are sampling from is normally distributed. Since that's not provided to us, we move on to the second thing. By the central limit theorem, if our sample size is large enough, we use 30, we can perform normal calculations. Unfortunately, our sample size here is 20. So the last thing that we have to do, and the only other option, is to graph our data and see whether a normal probability plot looks okay. So I've already entered the data into my list. You can see that here. So I'm going to go to my stat plot. I'm going to turn my plot on. I'm going to graph the last type of graph, which is a normal probability plot. And I'm going to do my shortcut of zoom 9 to get to my data. Now, this does have a linear pattern. Maybe it's not perfectly straight, but we're going to proceed with caution, saying that yes, we can perform inference on this set of data. So now we want to create a confidence interval. A confidence interval is found by taking the statistic that you are trying to the statistic you are using to estimate your parameter. For instance, you're either going to use the sample mean or the sample proportion. We're talking about sample means. So it's a statistic plus or minus the margin of error. The margin of error is found by taking your z or t critical value, depending on whether you know the population standard deviation or not, and you multiply that by the standard error of the statistic. Standard error, which is also abbreviated as capital S, capital E. The standard error is equal to the population divided by the square root of size n. And we saw this when we were doing our sampling distribution data. Our standard deviation of our sampling distribution was equal to the population standard deviation divided by root n. And that's what we're using here. So you might be given raw data like we have here, or you might be given summary statistics, and so you just need to know how to pull that information correctly. So for this particular problem, we're going to be dealing with our statistic, which is x bar plus or minus our z critical value, and we're going to multiply that by our sigma over root n. Something that is written further on down the problem that I didn't copy and paste here is that we do know that for this restaurant, the standard deviation for average percentage of tips is 2. And so we are going with the assumption that this is known information, which is why we're using a z-value. Well, I'm going to run my summary statistics and pull my x bar. I'm using L1. My x bar is equal to 22.21. Because I haven't given myself a confidence level yet, I'm going to do a 95% confidence interval. I would use a z critical value of 1.96. The standard deviation of the population was given to us as 2, and our n is 20. So creating the confidence interval would be 22.21 plus or minus 1.96 times 2 divided by the square root of 20. Subtracting would give us the lower bound. So we're going to do 22.21 minus 1.96 times 2 divided by the square root of 20. And that's going to give us our lower bound of 21.333. If we take that same expression and we change it to a plus sign, we'll get our upper bound, which is 23.087. So what I can do here is I can say that I am 95% confident that the interval 21.333 to 23.087 captures the true population mean of the tips for this restaurant. And that's all I have for you today.